This video will walk you through the answers to one of the versions of the limiting reactant summative assessment. There were multiple versions of the assessment. The answer key is in Canvas, so you've got your version plus a couple others that you can use to study from. And then in this video, we'll kind of go through the answers in a little more detail. The first was a simulation that we had done early on in this unit where we were given a recipe for a ham and cheese sandwich. We want to know, with the amounts of ham, cheese, and bread that we have, how many complete sandwiches can be made. So I have to look at the ratio from my balanced equation. This ham and cheese sandwich requires 2 pieces of bread, 1 piece of ham, 1 piece of cheese. So some people like to group them together in that ratio or kind of cross them off in that ratio. Every time I can group 2 pieces of bread, 1 piece of ham, and 1 piece of cheese, all of this will give me 1 complete sandwich. And then I see how many times can I do that. So I can make 1 sandwich, then here's 2 pieces of bread, 1 ham, 1 cheese. All right, there'd be another complete sandwich. 2 bread, 1 ham, 1 cheese. There's 3 sandwiches. I can do it one more time. 2 bread, 1 ham, 1 cheese. But then that's it. I'm going to run out of bread, which would be like our limiting reactant. So we can make a total of 4 complete sandwiches. And then I'm going to have some excess. 2 extra ham and 2 extra cheese. But I ran out of bread, so it limits the amount of product I can form. Now in the next section, it's still the same concept, but instead of ham and cheese, we're looking at real molecules in a balanced equation. In this equation, I've got 1 ethylene reacting with 3 oxygen. Question A, what is the limiting reactant? So kind of similar to the last example, I'm going to group my reactants together according to the ratio in the balanced equation. So every time I can find 1 ethylene, that's the C2H4, and 3 oxygen, I'm going to group those together. Now that's the ratio of reactants in my balanced equation. So for every 1 ethylene and 3 oxygen, this grouping should make 2 carbon dioxide and 2 water. Again, that's the ratio in the balanced equation. And I'm just going to do that as many times as I can until I run out of something. Every time I can group, let's see here, 1 ethylene and 3 oxygen, this grouping would make 2 carbon dioxide and 2 water. And we keep going. Oh, let's see here. I think I can do it one more time. I see 1 ethylene and 3 oxygen, and that grouping should give me 2 carbon dioxide and 2 waters. The ratio in the balanced equation. Okay, but now that's as far as I could go. At this point, I've used up all my oxygen. Some people like to group like this. Some people will cross off every 1 ethylene and 3 oxygen. They'll cross them off to show that they've been reacted. That's great. But now it looks like I've got 1, 2, 3, 4 ethylene in the middle that are just left over, unreacted. So I ran out of oxygen. That's my limiting reactant. How many total carbon dioxide and water can be produced? 6 of each. I can run the reaction completely 3 times. So I've got 246 carbon dioxide and 246 total water. Part C, my excess reactant is the C2H4. There are 4 of them left unreacted. And finally, part D, I have mole amount. So now we've looked at sandwiches, something that maybe I'm more familiar with. We've looked at particle models. So the next step would be moles. The ratio in the balanced equation could be thought of as a ratio of molecules, or on a larger scale, we would use it as a mole ratio. If I had 2.5 moles of ethylene react with 8.1 moles of oxygen, which will be the limiting reactant? Justify with a calculation or an explanation. Now, if you choose the calculation route, you pick one of those reactants. It doesn't matter which. I just picked the one that came first. You set up a little proportion, cancel the reactant that you chose, and switch it to the other reactant. I plug this in, which would be a super easy ratio, so maybe you would even be able to do this in your head. According to the balanced equation, I need 3 times as much oxygen. So if I have 2.5 moles of ethylene, I need 7.5 moles of oxygen. Now that's what I need. And I always write that word in there so that it's not just a number, it means something. That's the amount of oxygen I need. What was given to me in the problem, that's what I have. So I have 8.1. I need less, I have extra. So oxygen's the excess. By process of elimination, the C2H4 ethylene must be the limiting. Now you could start this calculation, if you choose to do the calculation, you can start with either reactant. In this case, if we have more than what we need, we found the excess. But let's say I would do this calculation and it says that I need 7.5 moles of oxygen, but what if I only had 6.1 instead of 8.1? If I don't have enough, if I have less, then that's the limiting reactant. All right, so if I can do limiting excess ratios with common everyday items like sandwiches, I can use the ratio in the balanced equation to interpret a particle model, a mole ratio. And the last step is grams. So this is where it becomes more like real world lab application. In the lab, we're going to measure everything in grams. But in order to determine a limiting reactant or an amount of product formed, I have to use the mole ratio in the balanced equation. I've been given the reaction. This is copper reacting with silver nitrate. It's already balanced. I have 10 grams of copper added to 34 grams of silver 1 nitrate, and I need to calculate moles of each reactant. Eventually, I want to compare moles of reactant using that 1:2 ratio from the balanced equation. But that's got to be a mole ratio. So first order of business, cancel grams, get those reactants in moles. Make sure you have your molar mass correct. I can just add those molar masses off my periodic table. So for example, that 169.88, that's silver plus nitrogen plus 3 times the mass of oxygen. Then part B, I can figure the limiting reactant. And again, I can justify with a calculation or an explanation. Because again, this ratio is not super crazy, 1:2. So you pick one reactant, it doesn't matter which. If I look at the balanced equation, I need twice as much silver nitrate. So maybe you could just do that in your head or in your calculator. Or if you want, you can set up the proportion. I picked the copper, so I'm going to cancel copper and switch it to moles of silver nitrate. Now you could pick either reactant and switch it to moles of the other. And I still write it in that what I calculate here, that's what I need. What I was given in part A, that's what I have. I need 0.314 moles of silver nitrate, and I do not have that. I have less, only 0.2 moles. I found the limiting. Silver nitrate is limiting, or maybe you would have found that copper was excess. So by process of elimination, the silver nitrate is limiting. I'm going to use that limiting reactant then to calculate grams of silver that would be produced. Well, if I run out of silver nitrate, then I can't make any more silver metal. The amount of silver is limited by the amount of silver nitrate I have to start with. So we always do our calculations, starting with the limiting reactant. Now, a couple things here that obviously I have to start with the silver nitrate. You can go back to the 34 grams, that's what we have. Or since I already converted it to moles, you can start with the 0.2 moles. Eventually now, I want to be able to convert between my limiting reactant and the amount of silver produced. I want to be able to use that 2:2 mole ratio. To take a shortcut, if you already have moles of silver nitrate, start there. Alright, so I got moles of silver nitrate. I'm going to use the ratio in the balanced equation to get over to moles of silver. And then once I've got moles of silver, I can convert it back to grams of silver. And there we go. Plug it all in your calculator, about 21.6 grams of silver produced. Now, this next part is going to look just the same. It's going to look just like part C. The limiting reactant runs the show. It determines how much product can form. When I run out of silver nitrate, the whole reaction is going to stop. So I won't make any more product. And I won't use any more of the excess reactant. So we're going to do almost the exact same calculation, but instead of turning it into a product, we're going to go from our limiting reactant to our excess reactant, which is the copper. But all calculations must start with the limiting. So again, I'm starting this the exact same way with that 0.2 moles of silver nitrate. I'm going to use the ratio between silver nitrate and copper to get over to moles of my excess reactant, that's the copper, and then we'll turn it back into grams. So that's 63.55, that's just the molar mass of copper from my periodic table. Now this is the amount of copper that gets used, the amount of copper that gets reacted. So finally in part E, we want to know how many grams of the excess are left over. So I go all the way back to the original problem. I had 10 grams of copper to start with. I'm only going to use 6.36 grams. So the difference is the amount of copper that's left over, that's left unreacted. Now all of the sample assessments will follow the same general trend. It's the same kinds of questions. It might just be a little different reaction or different numbers. So hopefully this video kind of helps you, and then you can follow along with any of those other samples.